All right. So our two tricks today, two-way tables and Venn diagrams. The reason they're so useful is because you can see every element in the sample space. The sample space is just a list of all the possible outcomes. And so this first two-way table is done for you. So if you get a two-way table done for you, you should be very happy. This is about high school graduates and non-high school graduates using laptops and desktops. So if we choose someone at random, we'll do our notation like this: probability of high school graduate, HSG, high school graduate equals, and let me just move this up a little bit. Probability high school graduate. So what do you think? How many high school graduates? Yeah. Would you mind turning off one of the lights over there? The other one. Yeah, great. Okay, high school graduate is, how many high school graduates do we have? 340. And then, the total people in the sample space is, all 500 people are accounted for. Leave your answer like that, please. That's the work you would show. Let's get a little trickier. Probability high school graduate. And let's use notation for and. We're going to use an intersection symbol. That's an and. It looks like an N intersection. It kind of looks like an A too for and. A laptop. This will go in your notes too. So it's like the intersection. You both are a high school graduate and you have a laptop. Where do you find that? Which number is that? Yeah, 221 right here. And we're still dividing by 500. We're not always going to, but so far so good. And then now we're going to do or. So this is going to get a little bit trickier. High school graduate or. So we're going to use U for union for or. A laptop. And so we want to find all the people that have one or the other or both. So high school graduate, you look here and there's 340, right? There's 340 total high school graduates. And then we can add the people that have the laptop. We just look in this column, it's 310. But what's the problem with adding those up? Yeah, well, for one thing, it's more than 500. So clearly we've done something wrong. We've duplicated. So what do we need to subtract? Who are the people we've added twice? The high school graduates that have a laptop. We can't count them twice, so we need to get rid of them. This is going to help you understand the formulas. But we're still just dividing by 500 because it's still basic probability. It's not conditional. So that'll help you understand the formulas, okay? We can leave it like that because we just want to show how we get it. And now we're getting a little bit fancier. Probability high school graduate, given that, and the symbol for given that is this vertical bar. So make a note if you need that. Given that you own a laptop, what is the probability you're a high school graduate if you own a laptop? So now what you divide by is a little bit trickier. So I want to do that part first. You only look at, here's the key, only look at the column that's for laptop. So I'm going to highlight that one. So only look at this, that's the condition. We only care about this column. That's it. We're not going to look at any other numbers because that is the condition. So now what's the high school graduates that own a laptop? 221, but what do we divide by? 310, not 500. Okay, so that's how that changes the probability because we're looking at that condition. Questions on one? Yeah.
For letter C.
Letter C.
Like I just added. Yeah, I got so I added 340 and then I just added 89. Is that fine too?
340 plus 89. That should give you the same thing, shouldn't it?
Yeah.
Yeah, that's and totally fine.
We just write it as like 429 out of 500.
Yep.
We have to write the plus minus stuff.
No, you can just write 429. Oh. Is that what this is?
Yeah.
429 out of 500. So this is better to write it like that. Yeah. Yeah, that's totally good. More than one way to do these. More than one way to skin a cat. Okay. Sorry, cat lovers. All right. Next example, we have another two-way table that's all done for us. Lovely. That makes our life easier. This is about students and teachers that like different dances. So what's the probability that a randomly selected person likes the tango? We'll just say it's regular tango. It is, what is it?
26 out of 100.
Good, 26 out of 130, no problem. Now, the probability of randomly selecting a teacher who likes to salsa dance. So that is written like this. Probability that you like, the person likes to salsa given that they're a teacher. So we get more practice here. Again, you're only looking at now the teacher column row, teacher row, because that's the condition. You got to be a teacher first. And then we want to know about salsa. So that is what is it? 25 over 60. Yeah. Okay. And then the selecting a waltz lever who is a student. So you're going to do student. And the condition is that you're a waltz lever. So you're going to go to only this column, and then you do 12 over 25, it looks like, yeah? Yeah. 12 over 25. Okay, now it gets better. If you're bored, it gets better. Yeah.
Does it, when we're writing, like, the probability of the students, what does it matter? Like, which
Yeah, it does. The probability changes in the order that you do it. So generally speaking, whatever you see first, if it looks symmetric and you're not sure which is which, take the first thing that you see and make that you're given that condition. So it's like selecting a teacher, so that's given that you're a teacher. Yeah. Because it is hard to tell sometimes. Okay, now what I love about this is it blends. First of all, you have to do the two-way table, which is more typical. And then we get to see the same representation with a Venn diagram, and we get to see a formula. So this is going to combine 3 of the 4 methods all in the same problem. So this is awesome. So we're gonna fill in this two-way table. Let's take we'll go ahead and read it for a minute. 20 seconds, 10 seconds. Okay, so let's take the 78%, where that would be 78% drive over the speed limit. Where does that go? 78% said that's the total. Yeah, the drive over the speed limit. So 0.78 is the total. The beautiful thing is that these self-check, because it's like Sudoku, like the columns have to all add up to, what do they have to add up to?
No, it's not good. That's a one piece. It's not something.
Oh, never. Okay.
Yes, but that's necessary.
Okay, it's like a math crossword puzzle. Let's just put it like that. So 78%. Okay, 80% goes where? Distracted, right? Total distracted. 0.80. Because once we have this filled out, any question is easy to answer, no matter how it's phrased. When we have a two-way table or a Venn diagram. Okay, so we got that, and then where does the 60% say they do both? 60% goes where? Just right, this upper row, first column, 60%. So now is where the crossword puzzle comes in, because this has to add up, right? If 60% are distracted and 78% total, then what does not distracted have to be? 0.18, yeah. And then what does this have to be for these to add up for distracted? 0.20. And then what is, what can we do next? This way, right? 0.20. So therefore this has to be 0.02, and this has to add up to 0.22. Very good, very good. Okay. So now we're going to make the same picture with a Venn diagram. So you do, sometimes Venn diagram is like the only way to think about something. It's just the easiest way. So you always make, since there's two conditions, you make two circles. If there were three, you would make three circles. And then you make a box around the whole thing to represent the whole sample space. So everything in these spaces have to add up to 1 if we do it right. And we're going to say O for over the speed limit. Well, I'll just write the words. Over speed limit. That circle is for over the speed limit. And this circle is for distracted. Okay, so let's start with the very center. What percent are over the speed limit and distracted? What's the intersection of O and D is 0.6, right? Yeah. How about just distracted, but not over the speed limit?
20%.
Just distracted, but yeah, 20%. Good. So notice the entire circle adds up to 80%, which is what our total for distracted is. So we know that's correct. What about just over the speed limit? 18%, right? And so notice these two add up to 78%. And then any really good drivers on the outskirts in the space? Just 2% out here that are neither speeding or distracted, only 2%. So now we can see how easy questions are to answer. So let's do the first one using our Venn diagram. So using the power of the Venn, we want to know the probability a teenager does at least one of the two risky driving habits. So what do we add up?
Would you just say what you don't have?
Okay, so you could do the complement. So you could, I think that's what you're saying, Kyle, is just do 1 minus 0.02. So I like that because we could use the complement rule, and that is also a formula. You can just do 1 minus 0.02. So those are the people that don't do either, and that's 0.98. Probability is often simplest done that way, or what's the other way?
Add up,
What do we add up?
add up all the area within the circle.
All the area within the circles, good. So 0.18 plus 0.60 plus 0.20. Do we have to subtract anything out? No, because we already, these are unique people. There's 18% here, 60% here, 20% here. We didn't add up any overlap, so we're good with that. Just because someone does both, they still count. We counted them once. Or now I have to show you the formula because that way you'll understand it. The formula that's given for any test is this. Probability of A or B, A union B, is equal to probability A plus probability B minus the probability of the intersection, A intersect B. This is going to go, it's given in your notes. It'll be, and let me show you why it works. Because in this particular case, the probability of A, do you see how it's 0.80? That's like over the speed limit is 0.80, the whole circle, right? You'd add the whole thing. Plus the probability of B distracted is 0.78. That's the entire circle. But if you do it that way, you do have to get rid of the overlap, which is 0.60 for people that did both, because we counted them twice. By taking the entire circle, this plus this, we added these people twice. So that will also give us 0.98. And now you can see visually. So we've done a two-way table, Venn diagram, formulas, and then let's do this really quick. Probability of teenagers is only a distracted driver. Only distracted. Just look at the diagram. Only distracted right here. Right? 0.2. Only distracted, that's your answer. Because you drew a Venn diagram. So